Hey folks, welcome to this episode on drawing some covalent structures. We've been tasked to draw the polyatomic ion nitrate NO3 1 minus, and what we're going to do is we're going to use the math method to figure out how many sticks, aka bonds, as well as lone pairs we need, and then arrange the molecule and finally draw it. So the first step, if you looked at the previous videos, was to figure out how many valence electrons each of these atoms are coming in with. So we have nitrogen and oxygen. We have one of these, and we have three of these from our equation. Now, nitrogen is in group 5, so it has 5 valence electrons, and oxygen is in group 6, so it has 6. So if we multiply these through, we'll have 5, and we will have 18. Now, notice that we also have a charge on this nitrate, and so we have to take that into account. We're going to take that into account right here. Now, if it has a negative charge, that means that somewhere in the structure it has an extra electron. So what we're going to do is we're going to add an electron to this count. So now what we have is we have 6 plus 18. We have 24 electrons right now that this is coming in with. Step number 2 is to see how many these atoms would need to have a full outer shell. Now we're not looking at losing or gaining. We're looking at how many electrons in total. So once again, there's one nitrogen ion atom and 3 oxygen atoms. Both nitrogen and oxygen need 8 valence electrons to have a full outer shell. So if we multiply this through, we'll get this, add them together, and we get 32. All right, now they would need 32, but they only have 24. So we're going to figure out how many they actually share right now. So we'll do 32 minus 24 gives us 8. Now they share electrons in pairs. So we are going to divide it by 2, and we're going to get 4 sticks. Now those 4 sticks, again, can be used in any configuration. We can use a single stick to make a single bond. We can put 2 sticks together to make a double bond, or 3 sticks together to put a triple bond. So we're going to have to see how that all plays out once we arrange our atoms. Number 4 is to see how many electrons we have left over. We start off with 24, and we are using 8 from sharing these electrons, which leaves us with 16. Divided by 2, because again, lone pairs are in pairs, so we divide by 2, and we will get 8 lone pairs. Now, once again, to show where all these numbers are coming from, this is our 24. This is the same 24 we're using here and here. The 32 that we mentioned over here is the 32 that we're putting over here. And the 8 that we had here that we're sharing are the same 8 that we have over here. So that's kind of where all the numbers are being used. Now, it's time to arrange our atoms in some kind of configuration. The one that we want to put into the center is the one that has the most unpaired electrons. And so nitrogen, if you were to do the Lewis dot diagram, it's in group number 5. It has 3 unpaired electrons, while oxygen is in the 6th group, and it's going to have 2 unpaired electrons. So nitrogen is going to go in the center. So we're going to put nitrogen in the center, and we're going to treat the area around this nitrogen as a giant circle. So if we take a 360-degree circle and divide it by the 3 oxygens that we have, again, we have those 3 oxygens right there, we would get 120 degrees. So what we want to do is take into account this circle. We'll put 1 oxygen atom at the top, 1 over here, and 1 over here. And that's about 120 degrees. So this right here is about 120 degrees separation between the two. Now, the next step is that we have to connect this oxygen to the nitrogen. And we're going to do that using a stick, stick, stick. However, if you look, we actually have 3 sticks, and we calculated that we have 4. So we're going to have to place an extra stick, and that's going to be going between the nitrogen and an oxygen. Now, all of these oxygens and nitrogen bonds are the same. You could technically put them in any position. We're going to put it at the top because by convention, the thing that's going to be different usually exists at the top of our drawing. And so in this case, we'll put that double bond. Now, this NO3 does rotate in 3D space. It will rotate clockwise, counterclockwise. It will rotate towards you, away from you. And so this double bond, where you kind of place it, doesn't really matter. But again, by convention, when we draw it, we're going to put the thing that's different at the top. So we've been able to use all of our 4 sticks. Now we have 8 lone pairs, and we have to use those to satisfy octets. So if we look at our oxygens, this oxygen in particular only has 2 electrons to begin with. That 2 is found here. It's in the bond. It's sharing 2 electrons. So by putting another 3 pairs of electrons, we now have 8. That oxygen is good. We're going to do the same thing to the other oxygen atom here. And now this oxygen atom has 2, 4, 6, and 8 electrons, so it is good as well. It's going to delete those there. And then finally, we have used 6 out of the 8 lone pairs. The other 2 lone pairs are going to go on this oxygen atom. And that's going to give us, again, 2, 4, 6, and 8. That double bond is sharing 4 electrons in total. So those oxygen atoms are all good. So there we go. We've drawn this structure. The only thing that we need to do is to express the charge, and we're going to do that using square brackets and putting the charge outside of the square brackets. Hopefully that was helpful. Thanks for watching, and tune back for another example.